Mr. Chairman, let me thank you to give us the possibility to present our results about kinematic analysis of the knee barrier navigation system. And let me acknowledge my co-authors. Our disclosures. To restore physiological kinematics is one of the targets of a total knee arthroplasty. Navigation assistance was developed to increase accuracy of TKA. It may be used as a tool to register knee kinematics as well. The hypothesis of this study was that the registration of the knee kinematics during a passive movement of flexion by the navigation system will not differ from the registration of the same movement at the same time by a fluoroscopic technique. 5 pairs of gross specimens were used. The used TKA was the Emotion FP system from the Vibron Esculap company, and the navigation system used was the Autopilot TKA version 4.3 with the so-called kinematic Kobe version from the Vibron Esculap company. We performed a simultaneous registration by the navigation system and by the fluoroscopic system during a passive knee bending after performing TKA. Kinematic data were extracted from fluoroscopic registration by the John Track Auto software from the University of Florida. And these data were analyzed with the MATLAB software from MathWorks Incorporated. This analysis transformed the fluoroscopic images into mathematical data, which were compared to the mathematical data extracted from the navigation software. Data of interest were the HKA angle, the femur internal and external rotation, the anteroposterior femur translation, and the femorotibial gaps measured on the medial and on the lateral joints. We obtained 20 complete kinematic data. We observed a good intra-class correlation coefficient for HKA angles and gaps measurements. However, we observed only medium intra-class correlation coefficient for femoral translation and femoral rotation. These differences may be explained by a technical bias. For the navigation system, the femur reference is the posterior bicondylar line. For the fluoroscopic system, the femur reference are the more distal points of the femoral condyles of the TKA. So, navigation reference frame is more proximal and more posterior than fluoroscopic reference frame, and this may be explained the difference observed. We are currently performing an additional analysis after correction of this bias. I hope to be able to give you these results during the next year. I thank you for your attention.